I built Apple by refusing to listen to the market, and I need you to understand what that actually meant, because the phrase itself has been turned into something it was never supposed to be. People repeat it now as if it were some kind of rebellious stance, some courageous defiance of convention. They treat it like a personality trait, as if I simply had more conviction than other executives, more vision, more willingness to trust my gut. That is not what happened. What happened was structural, not emotional. It was a decision about where to locate the source of product definition, and that decision had nothing to do with courage. Let me state the tension directly. Every business school, every marketing department, every consultant who walked through a corporate door in the last 50 years operated on the same foundational belief, that the customer is the ultimate authority on what the customer wants. This belief feels unassailable. It sounds like common sense. If you want to sell something, you ask people what they want, and then you build that. The market speaks, you listen, you respond. This is called being customer-focused, and it is treated as the highest form of commercial intelligence. I rejected that model entirely, and Apple succeeded because of that rejection, not in spite of it. Now, before you misunderstand me, I need to be precise about what I am not saying. I am not saying that customers do not matter. I am not saying that you should ignore feedback or data. I am not saying that arrogance is a business strategy. What I am saying is that the conventional model, ask the customer what they want, then build it, is based on a false assumption about where product innovation actually originates. And that assumption, when followed, leads directly to mediocrity. Here is the assumption, that customers can articulate, in advance, what they will value once it exists. This assumption is everywhere. It is embedded in focus groups, in surveys, in user research, in beta testing. It is the reason companies spend millions of dollars asking people what they think about products that do not yet exist. The logic seems airtight. If you are going to invest resources into building something, you should first confirm that people want it. You should de-risk the process by gathering evidence of demand. This is the false model. And I operated inside it myself early on before I understood why it failed. When we were building the Macintosh, we did user testing. We brought people in, sat them in front of prototypes, watched how they interacted with the interface. We asked them what they liked, what confused them, what they wanted to see. And the feedback was useful in certain narrow ways. It told us where the friction was, where the language was unclear, where someone might get stuck. But it never, not once, told us what to build. The reason is simple, and once you see it, you cannot unsee it. People cannot tell you what they want if they have never seen anything like it before. Their frame of reference is everything that already exists. When you ask them to imagine something new, they do not imagine new, they imagine better. Better versions of what they already know. Faster, cheaper, smaller, more convenient. They optimize within the existing category. They do not, because they cannot, describe a different category entirely. This is not a failure of imagination on their part, it is a structural limitation of the question itself. You are asking them to want something they have no context for, and what they give you in return is a list of incremental improvements to things they already understand. If I had asked people in 1980 what they wanted, they would have told me a better typewriter. If I had asked them in 2000, they would have told me a better Walkman, a better phone, a better camera. They would not have described an iPod. They would not have described an iPhone. Not because they were not smart, but because those products did not yet exist in their mental models of what was possible. The market, in other words, is an excellent feedback mechanism for things that already exist. It is a terrible generative mechanism for things that do not. And this is where the mistake is. The mistake is believing that because customers are the ultimate judges of value, they must also be the source of definition. That because they decide whether something succeeds, they must also be able to tell you what that something should be. This conflates two entirely different functions, evaluation and creation. The market is superb at the former. It is nearly useless at the latter. I did not ignore the market because I thought I was smarter than everyone else. I ignored the market because I understood that the question I was trying to answer, what should this product be, was not a question the market could answer. It was a question that required a different method entirely. That method was not intuition. It was not taste, though taste played a role. It was not vision in the mystical sense. It was something more specific and more reproducible than people realize. It was this. I built products by starting from a position of internal clarity about what the product was supposed to do, and then I worked backward to make that real. Notice the direction, not from the market inward, from the idea outward. This is not arrogance. This is sequence. You cannot ask people what they think about something that does not yet exist in a coherent form. You first have to make it exist, at least in your own mind, with enough precision that you can describe its function, its boundaries, its reason for being. Only then can you begin to build it, and only after you have built it can the market tell you whether you were right. Chapter 2. The Mechanism of Creation. Now let me tell you what actually happened inside Apple, because this is where the misunderstanding becomes dangerous. People hear, "We did not ask the market what to build," and they conclude, "We sat in a room making arbitrary aesthetic choices," that we relied on taste or instinct or some mystical design sense. This is the second myth, and it is as false as the first. Here is what they imagine. A small group of visionaries sitting around a table, sketching beautiful objects, trusting their gut feelings about what would succeed. This is the romantic version. It appears in every business school case study, every biography, every conference presentation about innovation. And it is structurally identical to the market-driven model it claims to oppose. Both models assume the same thing, that product definition is fundamentally arbitrary, that it comes from somewhere outside a logical process, either from customer surveys or from designer intuition. One says, the market knows, the other says, the genius knows. But both treat the origin of product ideas as a black box, a mysterious generative moment that cannot be examined or replicated. That is not what happened at Apple. What happened was a systematic process of reasoning backward from fundamental principles. Not, what do people say they want, and not, what do I feel like making, but rather, what is the actual problem, stated precisely, and what are the structural requirements of a solution? Let me give you the example everyone thinks they understand. The iPhone. The conventional story goes like this. Steve Jobs had a vision of a beautiful touchscreen device, and he forced it into existence through sheer will and perfectionism. This story satisfies people because it preserves the mystery. It allows them to say, well, of course Apple succeeded. They had Steve Jobs. It makes innovation into a rare gift rather than a reproducible method. Here is what actually occurred. In the early 2000s, we looked at mobile phones and identified a structural problem. The interface was defined by the hardware. Every phone had a fixed keyboard, physical buttons in a permanent arrangement. This meant the interface could never adapt to the task. If you were typing a text message, you needed a keyboard. If you were looking at a photo, you needed a large screen. If you were dialing a number, you needed a numeric pad. But the hardware could only be one of those things at a time. The manufacturer's solution was to optimize the compromise. Better button layouts, smarter menu systems, smaller physical keyboards. This is what the market research recommended, because when you asked people what they wanted in a phone, they described better versions of the phones they already had. But we did not ask, what phone do you want? We asked, What is the structural constraint that makes all current phones inadequate? And the answer was, the interface cannot reconfigure itself. Once you state the problem that way, the solution space becomes clear. You need a display that can become whatever interface the current task requires. A keyboard when you are typing, a photo when you are viewing, a video player when you are watching, a canvas when you are drawing. The hardware must be neutral, a blank surface that software can transform. This is not a guess. This is not intuition. This is deductive reasoning from first principles. Now, before you misunderstand me, I am not saying the iPhone was inevitable, or that anyone could have built it, or that the execution was simple. I am saying the concept was not arbitrary. It was not a matter of taste. It was the logical answer to a precisely stated problem. And here is the critical point. The market could not have told us this. Not because customers were not smart, but because the question, what is the structural constraint that makes all current phones inadequate, is not a question the market can answer. The market can tell you what is inadequate. It can tell you phones are too hard to use, too limited, too frustrating. But it cannot tell you why, in structural terms. It cannot identify the underlying architectural problem. That requires a different kind of analysis. It requires taking the product apart conceptually, understanding what each component does and why it must be that way, and then asking, which of these necessities are actually contingent, which constraints are fundamental, and which are merely inherited from previous solutions. The market cannot do this work. The market experiences the product as a unified whole. It encounters friction and expresses dissatisfaction, but it cannot decompose the product into its logical structure and identify which element is causing the systemic problem. Let me give you another example, smaller and more specific, because I need you to see that this method applies at every level of product development, not just to the grand vision. When we built the first iPod, we faced a simple question. How should the user navigate through 1,000 songs? The existing MP3 players used a directory system borrowed from computers, folders and subfolders, organized by artist or album or genre. You navigated with arrow buttons, up, down, left, right, select. The market research said this was fine. Users understood folders. They were familiar with the concept from their computers. When asked what they wanted, they said, faster navigation, maybe more buttons, perhaps a touchscreen to tap through the menus more quickly. But we identified the structural problem. Directory navigation requires you to remember where you put things. If you want to hear a specific song, you must recall whether you filed it by artist, or album, or playlist. You must retrace a path through a hierarchy. This works acceptably when you have 50 songs. It becomes unbearable at 1,000. The problem was not the speed of navigation. The problem was that the interface required memory work. It asked you to maintain a mental model of the directory structure. Once you state it that way, the solution requirement becomes clear. The interface must allow direct access without hierarchical traversal. You must be able to reach any song without remembering where you categorized it. The scroll wheel was the answer to that precisely stated problem. It allowed you to move through an alphabetical list at variable speed, slowly when you were close to your target, quickly when you were far away. It eliminated the hierarchy. Every song was equidistant, a matter of scrolling, not of remembering and navigating. Again, this was not an aesthetic choice. It was not a matter of, I like wheels. It was a logical solution to a structural problem that we identified through analysis, not through market research. And here is what I need you to understand. This is a method. It is not magic, it is not gift. It is a systematic process of problem decomposition and logical reasoning. First, identify what users find inadequate about current solutions. The market is superb at this. Listen carefully to complaints, frustrations, workarounds. These are symptoms. Second, analyze the product's structure to determine which component is generating those symptoms. This is the work the market cannot do. It requires technical understanding and conceptual decomposition. Third, state the structural problem precisely. Not, users want faster navigation, but the interface requires memory work that does not scale. Fourth, reason from that problem statement to the requirements of a solution. Not, what should we build, but what must be true of anything that solves this problem. Fifth, build to those requirements, and only then, only after the product exists, let the market evaluate it. This is what I mean when I say we did not ask the market what to build. We asked the market what was broken. We did the analysis ourselves. We stated the problem ourselves. We derived the solution requirements ourselves, and then we let the market judge whether we had succeeded. The market is the evaluator, not the creator. And the creator is not a mysterious genius. It is a systematic analyst working from first principles. This distinction is not semantic. It is the difference between a reproducible method and an unreproducible gift. It is the difference between a company that can continue to innovate and a company that produces one successful product and then spends decades trying to recapture the magic. Apple succeeded not because we had better intuition, but because we had a better process. We knew which questions the market could answer, which questions required internal analysis, and how to move systematically from problem to solution. That is the mechanism of creation, and it is not a mystery. Chapter 3. The Generative Mechanism. Now I need to explain the part that makes people uncomfortable, because once you understand that the market cannot create, that it can only evaluate, the natural question becomes, then who creates? And the answer that most people leap to, the answer that has been used to dismiss this entire method as unrepeatable is, Steve Jobs creates, the genius creates, the visionary creates. That is not the answer. I am not saying I did not create the iPhone. I am saying that framing it as Steve Jobs creates the iPhone obscures the actual generative mechanism. It personalizes something structural. It turns a reproducible method into an irreproducible gift. And in doing so, it makes the whole thing useless to you. Here is what actually generates new product categories. Constraint-driven derivation from first principles. Let me state that again, because the phrase sounds abstract, and I need you to see it as concrete as a manufacturing process. You start with a constraint, a structural limitation in existing products that creates friction for users. Not a desire, not a wish, a constraint, something that cannot be solved within the current category architecture. Then you reason backward from that constraint to derive what properties a solution must have. Not what features people want, what physical, technical, or logical properties are required to eliminate the constraint. This is not vision. This is derivation. Let me show you what I mean with the example everyone thinks they understand. The iPhone. The iPhone. Derivation, not vision. The story people tell is that I walked into a room one day and said, I want to make a phone, and then through some combination of taste and tyranny, forced that vision into existence. That is not what happened. What happened is that I was using a phone in 2004. Everyone was using phones in 2004, and I encountered a constraint. The constraint was this. Every phone had a fixed physical interface. Buttons, keyboards, scroll wheels, and that fixed interface had to serve every function the phone performed. Now, here is the structural problem. Different tasks require different interfaces. Typing a message wants a keyboard. Selecting from a list wants a scroll mechanism. Viewing a photo wants no interface at all, just the image. Playing a game wants task-specific controls that change per game. But the phone had one interface: fixed, permanent, decided at manufacture. So every task was a compromise. The keyboard was too small for comfortable typing because it also had to include navigation buttons. The screen was too small for comfortable viewing because it had to share space with the keyboard. The controls for every application were awkward because they were generic, designed to work for everything, optimized for nothing. This is the constraint. A fixed physical interface cannot optimize for tasks with incompatible interface requirements. Now, once you state the constraint that precisely, the solution requirements become derivable, not obvious derivable. There is a difference. If the problem is that fixed hardware cannot adapt to varying tasks, then the solution must involve an interface that can reconfigure itself per task. That is not a feature request. That is a logical requirement derived from the constraint. If the interface must reconfigure, it cannot be physical buttons. Those are fixed. It must be a display that can render different interfaces, a screen. If the screen must render different interfaces, it must be large enough to contain a full keyboard when needed, a full photo when needed, full game controls when needed. That means the screen must occupy most of the device surface, not because large screens are nice, because the constraint requires it. If the screen occupies most of the device, physical buttons become impossible. There is no room. So all input must occur through the screen itself. It must be a touch screen. Do you see what just happened? I did not decide the iPhone should have a large touchscreen because I liked touchscreens. The constraint required a large touchscreen. The derivation led there inevitably. Now you might say, but other people knew about touchscreens. Palm had touchscreens. Windows Mobile had touchscreens. Why didn't they build the iPhone? Because they were not reasoning from constraints. They were reasoning from features. They said, touchscreens are interesting. Let's add a touchscreen to our phone. So they added a touchscreen and kept the keyboard, kept the navigation buttons, kept the stylus. The touchscreen became one more feature in a feature list, not the structural solution to a constraint. We said, the constraint requires that the interface reconfigure completely per task. Therefore, there can be no fixed interface elements, no keyboard, no buttons, no stylus, only the reconfigurable screen. That is derivation. That is the generative mechanism. Why this is not genius. I need you to understand why this is not genius, because if you think it is genius, you will not attempt it yourself. Genius implies a leap, an intuitive jump that cannot be explained or taught. You either have it or you do not. Derivation is not a leap. Derivation is a chain. Each link follows from the previous link according to logical necessity. The constraint requires reconfigurability. Reconfigurability requires a programmable interface. A programmable interface requires a display. A display large enough to contain full task interfaces requires most of the device surface. A device surface dominated by display cannot contain fixed buttons. There is no leap in that chain. There is only reasoning. Now, here is where people get confused. They say, but you had to see the constraint in the first place. You had to notice that fixed interfaces were the problem. That is the genius. No, that is attention. And attention can be trained. I trained myself to encounter products as bundles of constraints, not as finished objects. When I used a phone, I did not think, this phone is hard to use. I thought, which structural element is generating this friction? I decomposed the experience into components interface, processor, network, software architecture, and asked which component was the limiting factor. That is a skill, a practiced skill, not a gift. The reason most people do not see constraints is not that they lack genius. It is that they have been trained to see products as wholes and to report their emotional response to those wholes. I like this. This is frustrating. I wish this were easier. Those are evaluations, and evaluations do not generate solutions. To generate solutions, you must decompose the product into its structural elements and identify which element creates the constraint. That is analytical work, and analytical work can be taught. The role of technical knowledge. But, and this is critical, you cannot derive solutions from constraints unless you know what is technically possible. When I stated that the solution required a reconfigurable interface, I knew that touchscreen technology existed. I knew that processors had become powerful enough to render complex interfaces in real time. I knew that battery technology had advanced enough to power a large screen without the device becoming unusable. If I had not known those things, the derivation would have terminated. I would have identified the constraint, derived the solution requirements, and then concluded, this cannot be built. This is why technical knowledge is not optional for innovation. Not because you need to write the code yourself, but because you need to know what is possible in order to derive buildable solutions. The market does not have this knowledge. When you ask customers what they want, they do not know what is technically possible. They do not know that touchscreens can be made responsive enough for typing. They do not know that processors can render interfaces in real time. They do not know that batteries can power large screens for a full day. So when they imagine better phones, they imagine better versions of what currently exists. Better keyboards, longer battery life on existing designs, faster navigation through existing interfaces. They cannot derive the iPhone because they do not know the iPhone is derivable. But I knew, not because I was smarter, because I had spent 30 years learning what computers could do. I had built machines. I had written software. I had argued with engineers about what was possible this year versus what would be possible in 3 years. That knowledge was the raw material for derivation. And this is the part that makes people uncomfortable, because if innovation requires both constraint identification and technical knowledge, then the market cannot innovate. Not because customers are not smart, but because they do not have the technical knowledge required to derive solutions. And if the market cannot innovate, then companies must innovate internally. They must develop people who can identify constraints and derive solutions. They must build organizations where technical knowledge and product definition exist in the same heads. But most companies are not structured that way. Most companies separate business from technical. The business side talks to customers and defines requirements. The technical side builds what the business side specifies. That structure makes constraint-driven derivation impossible, because the people who talk to customers do not have the technical knowledge to derive solutions, and the people who have the technical knowledge do not talk to customers to identify constraints. So companies end up asking customers what they want, because that is what people without technical knowledge can do, and then building those requested features. And that produces incrementalism. Better, cheaper, faster, smaller. Never new. This is why I did not separate business from technical at Apple. The people who identified constraints were the same people who derived solutions. We did not hand requirements over a wall. We reasoned from constraints to solutions in one continuous process, with technical knowledge available at every step. That made people uncomfortable. It violated organizational orthodoxy. It meant engineers had to understand users, and product definers had to understand technology. But it was the only way to make derivation work. And derivation, not vision, not genius, not taste, was what generated the iPhone. Chapter 4. The constraint that became the iPod. I need to show you how this worked in practice, not because you need another example, but because the iPod revealed something most analyses miss. The constraint that mattered was not the one people talked about. Every retrospective account of the iPod begins the same way. They say, people wanted their music portable. They say, The MP3 player market existed, but the products were inadequate. They say, we saw an opportunity to make a better player, more storage, better design, simpler interface. And then they point to the scroll wheel as evidence of Apple's superior execution. That is not what happened. That narrative makes it sound like we entered an existing category and simply outdesigned the competition, as if the problem was known and we just solved it more elegantly. But this misunderstands both the problem we identified and the solution we derived. The scroll wheel was not better design. It was the necessary consequence of a constraint that no one else had properly identified. Let me state the actual constraint. In 2000, I sat with engineers and looked at existing MP3 players. The market had already told us what it wanted, or thought it wanted. People complained about storage capacity. They complained about battery life. They complained about the complexity of transferring files. Every review, every focus group, every competitive analysis pointed to these problems. Better, cheaper, more storage, easier syncing. The standard list of incremental improvements. And yes, those were real limitations. But they were not structural constraints. They were symptoms. Here is what I noticed. Every single player required users to navigate through hierarchical menus to find songs. Artists, then albums, then tracks. Or genres, then artists, then albums, then tracks. The deeper your music library, the more steps required. And here is what that meant structurally. The device was asking users to remember where they had categorized their music. Now, this seems trivial when you have 50 songs. You remember that Kind of Blue is filed under Jazz, under Miles Davis. But at 5,000 songs, the system breaks down. Not because users are forgetful, but because the cognitive work required scales linearly with library size, while human memory does not. The constraint was not navigation speed, it was that hierarchical systems externalize categorization work onto the user, and that work becomes prohibitive at scale. Do you see the difference? Navigation is too slow describes a symptom. The system requires memory work that does not scale describes a structural constraint. And here is where derivation begins. If the constraint is scaled memory work, then the solution cannot be a faster version of the same hierarchical system. Making the menus scroll faster does not solve the problem. It just makes users hit dead ends more quickly. The solution must eliminate the memory work itself. How do you eliminate memory work in a navigation system? You allow direct access. Not faster access through a hierarchy, but access that does not require remembering where something is categorized, which means alphabetized lists that users can scan directly. But now we have a new problem. An alphabetized list of 5,000 songs is itself unusable. Scrolling from A to Z one item at a time would take minutes. So the derived requirement becomes direct access to alphabetized lists at variable speeds, fast enough to traverse thousands of items in seconds, precise enough to land on individual entries. And this is where technical knowledge becomes essential, because now we can ask, what mechanism allows continuous, variable speed scrolling with precise endpoint control? Not buttons. Buttons are discrete, not continuous. Not a joystick. Joysticks require constant attention and lack the precision for single item selection. A touch-sensitive wheel allows continuous circular motion, can translate rotation speed into scroll speed, and can pair with a center button for selection. The scroll wheel was not a design flourish. It was the mechanism that satisfied the derived requirements. Do you see the chain of reasoning? User constraint, structural analysis, solution requirements, technical derivation, scroll wheel. At no point did we ask users, would you like a scroll wheel? At no point did we brainstorm interface ideas and pick the coolest one. We identified a constraint, derived what any solution must do, and built the mechanism that satisfied those requirements. Now, before you misunderstand me, I am not saying the scroll wheel was inevitable. I am saying it was derivable. Someone else, working from the same constraint analysis, might have derived a different mechanism, perhaps a touch strip, perhaps something we never considered. But whatever they derived would have to satisfy the same requirements: continuous input, variable speed, precise control. The specific implementation allows for variation, the requirements do not. And here is what that means for the question of market input. Could we have discovered this by asking users what they wanted? No, because users experienced the symptom-slow navigation, not the structure. When we did show early MP3 players to people and asked what frustrated them, they said exactly what you would expect. It takes too long to find songs. And if we had asked, what would solve this? They would have said, faster menus, better search, bigger screen to show more options at once. All reasonable responses, all addressing symptoms, none identifying the structural constraint. The market gave us the signal that navigation was a problem. That signal was valuable. It told us where to look. But the market could not tell us why navigation was a problem at a structural level, and therefore could not tell us what a solution required. That analysis required decomposing the interaction model, understanding the cognitive work it demanded, and recognizing how that work scaled. Could users evaluate the scroll wheel once it existed? Absolutely. Put an iPod in someone's hand, let them navigate a 1,000-song library, and they could immediately tell you whether it worked better than the alternative. The market is superb at evaluation, but it cannot do the analysis that precedes creation. Now here is where this gets interesting, and where most people who try to replicate this method fail. They hear identify constraints, and they think it means listen to complaints. So they collect user feedback, they run usability studies, they compile lists of problems, and then they brainstorm solutions. They ask, how might we make navigation faster? And they generate ideas: touchscreens, voice control, better search algorithms, personalized playlists. And some of those ideas might even work. But this is not derivation. This is brainstorming guided by symptoms. The difference is this: brainstorming generates options that you then test to see if they work. Derivation generates requirements that solutions must satisfy. One is exploratory, the other is logical. When we designed the iPod interface, we did not brainstorm 10 ideas and pick the best one. We stated the requirements: direct access, variable speed, precise control, and then asked what mechanisms could satisfy them. The scroll wheel was not selected from alternatives, it was derived from requirements. And this is why technical knowledge is not optional, because you cannot derive a mechanism without knowing what mechanisms are possible. If you do not know that capacitive sensors can detect rotational motion, you cannot derive a scroll wheel. If you do not know that variable scroll speed can be calculated from rotation velocity, you cannot design the interaction model. The business person who understands user constraints but lacks technical knowledge cannot complete the derivation. They stop at, we need faster navigation, because they do not know what faster could structurally mean. This is the part that makes people uncomfortable, because it suggests that the person identifying constraints must also possess deep technical knowledge. And in most organizations, that is not how roles are structured. The product manager talks to users. The engineer builds what the product manager specifies. The separation seems efficient, but it breaks the derivation chain. Because the product manager, lacking technical knowledge, cannot derive requirements. They can only describe desired outcomes. And the engineer, lacking direct exposure to user constraints, cannot validate whether the requirements actually address the structural problem. So you end up with specifications that say, make navigation 50% faster, rather than eliminate scaled memory work. And those are not the same thing. At Apple, I was not separate from the technical work. I had spent years building computers, writing code, understanding what components could do and how they could be combined. When we analyzed the navigation constraint, I was not translating user feedback for engineers. I was doing the structural analysis myself, with engineers, deriving requirements from constraints using technical knowledge we shared. This is not about me, this is about the method. The person who identifies the constraint must be able to derive the solution requirements, and that requires technical knowledge. Not coding expertise necessarily, but deep familiarity with what is technically possible, what components exist, how they behave, what they can be made to do. Could this be taught? Yes, but not in a 3-day workshop. It requires years of working directly with technology, building things, understanding systems at a structural level. There is no shortcut. You cannot separate business thinking from technical thinking and expect constraint-driven derivation to occur. The derivation happens in a mind that contains both. And this is why most companies cannot replicate this method even when they understand it intellectually. Because replicating it would require restructuring how they develop talent, how they define roles, how they organize teams. It would require training business leaders to think technically and technical leaders to identify user constraints. It would require decades of investment in building people who can do both. Most companies are not willing to make that investment, so they continue to separate the roles, continue to ask users what they want, continue to brainstorm solutions and test them with focus groups. And they continue to produce incremental improvements to existing categories, rather than new categories entirely. The iPod was not magic. It was methodical derivation from a properly identified constraint. But that method requires a kind of knowledge integration that most organizations are not structured to support. And that, more than vision or courage or taste, is why it is rare.